Well, hello everyone, and thank you for joining today's recorded webinar. My name's Nathan. I'm one of the regional sales engineers for TrapX, and my email address is just over here on the front slide. If you do have any questions following today's session, please feel free to drop me an email. I've put forward a very simple agenda today. We have about 20 to 25 minutes to walk through the architecture of Deception Grid, and then we'll spend most of the time in the live demonstration of the product. Today we're going to be demonstrating version 7 of Deception Grid. This is a brand new release. It came out in May this year, so lots of nice new features. We'll highlight some of those as we go through the demonstration. So just very quickly on the architecture of Deception Grid, the first two components that would be deployed in any solution are the TrapX Security Operations Console. We call that TSOC for short. This is our management console that manages all components of the TrapX Deception Grid platform. This is a virtual web GUI and incredibly easy to deploy. The second part of the first phase of deployment is the TrapX appliance. This is usually a virtual appliance, but we also do have physical appliances for customers or certain sectors that require physical devices to be deployed, and that includes not only a standard rack mount server, but we also do have a hardened, ruggerized device which can be sent out to remote locations such as manufacturing plants and that sort of thing. Anyways, the appliance is really where all of the magic happens in terms of our decoys. We are able to deploy over 500 decoys per single appliance. What's really important to note here is that you'll see we do support a number of different types of decoys. There's a selection shown here on the screen. There's much more than this actually in the product. And we can actually build things like Windows desktops, Windows servers. We also have the Mac OS support, and Linux servers can be easily built on the platform. But also we have a selection of sort of industrial systems, networking gear, and IoT platforms, and certainly it's very straightforward to, for example, deploy an SAP service or even a Siemens PLC if you're in the OT environment. So we'll show some of that in our demonstration. All of this is configured very straightforward on our appliance. We do not require any licensing from these vendors. We do not require any VM machine licensing. This is all built in the patented technology of the TrapX Deception Grid. To make this deception solution even more realistic, we have a number of additional parts to the solution. So we're able to build and deploy bait that can be sent out to real machines on your network. We call this deception tokens. The industry tends to call this honey tokens or lures. It's all the same thing. We have this ability to build these tokens inside the Deception Grid TSOC platform as a package file, and you can push that out either from the TSOC or in fact you can also send that to a third-party tool like SCCM, which is the most common way of deploying that to the network infrastructure. We also do have on here on the right hand side full OS traps. We have an agent that can be deployed to real machines in your network that can actually provide a high interaction trap for your environment. However, for today's demonstration, and just because we have a limited amount of time, we're going to be focusing on the medium emulation traps, decoys on the appliance, and some of the deception tokens that we can also roll out. We also have a very strong integration with the security architecture of the customer's environment. Here we have out-of-the-box plugins to common platforms such as SIM, network access control firewalls, and sandboxes, and also the ability to use an API for third-party interaction with systems that are not built into the product by default. Again, straightforward to do. One final note to mention here is that every appliance, whether it's physical or virtual, can plug into a network tap or span port at the egress of a network, and we can actually record outbound traffic on that sensors. So that's the architecture. The system is very scalable and it is very easy to deploy. And I'll move now over to the TSOC platform and show how we can build decoys really quickly. Right, so I will move into my browser interface. You can now see me connected into a TSOC dashboard. You'll notice that the first top of the screen here is actually quite empty. And the reason for that is currently there are no trap events that have been registered on this TSOC, so it's nice and clean. But of course, we're going to generate some traffic and you'll see some of that activity live. If I scroll down, what you'll see is a summary on the left-hand side of all of the traps that are currently configured on this appliance that's connected to my TSOC. And you'll see that here we have workstation traps, so Windows workstations and Mac OS. We have 2 Linux devices and 2 Windows devices. If I scroll down further, you will see that we also have some networking gear configured. Here I've got 2 networking traps. I also have a SAP and a SCADA system configured, and a final one at the bottom, an IoT. This one's actually a printer that we've configured as a decoy, and I'll show you that later. On the right-hand side, my threat stats are showing at the moment everything is 0. There's no traps that have been triggered. We categorize our events in a series of ratings here, from low severity here as a scan through to a high severity event as an infection on a machine. So this is a summary on the front screen when you first log into TSOC. But what we'll do now is have a look at the configuration of some of those existing decoys before we go and create a new one. So I'll log into the appliances section of my dashboard, and I'll expand the appliance that's currently configured out there, which as you saw on the main summary screen on dashboard, these are my existing traps that have been configured on this particular appliance. The trap here is called Demo File Transfer Server on IP address 90 on my network. This one's configured as a Windows Server emulation, and we have configured it to respond like it would do if it was a Windows 2012 server. Now, as I mentioned earlier, we do not require any licensing from Microsoft to perform this decoy deployment. If I expand the configuration of this FTP service, what you'll see here is everything is very much wizard driven. I can give my trap a name, I can apply an IP address to my trap, I can provide a host name and also a domain of this particular trap. So here I've called this FTP server. And then if I move through to my next configuration, I can select what type of category this fits into. Well, this one is a server, and this one's actually going to be Windows Server. But of course, I could have actually chosen, if I was in the financial services sector, I could actually choose a Swift platform or even an ATM machine. If I was in more of a manufacturing location, this might be an SAP or a SCADA device that I'm trying to provide a decoy for. So very straightforward. As a solution to roll out your decoys, I can move over to the actual services configuration here, and you'll notice I've selected a 2012 Windows server. So what that means is if an attacker comes into your network and does a fingerprint, an OS fingerprint scan, we will respond as if we are Windows 2012 server, but I could have chosen a legacy 2003 or even a 2016 server. So there's lots of options available. Here I've selected the services that I want to respond with, and I've already mentioned that this is an FTP server, so I've got FTP running. I also have SMB running on this particular trap, so it's acting also as an SMB file share, but the main demonstration I want to show you here is how we would respond with an FTP service. So I can go into my configuration screen, and very straightforward, I can change things like the FTP banner. So this is a Microsoft standard response here. I'm going to change this and just call this Nathan FTP service. I've left the authenticated user list as default. What that means is the trap is going to respond with allowing anonymous logins. But if I did want to make this more difficult for the attacker to gain access to, I could actually upload a CSV file to here that contains very simply usernames and passwords. And if I did that, the trap becomes more difficult. So I have set my banner. I now go to finish, and really that's all I need to do. So what the appliance will do is will actually create a decoy that is going to respond to an attacker like a Windows server with a number of services available. And what might happen is, let's assume an attacker has gained access to your network. One of the things he might do is use a tool like Mmap to perform some scans. And in my example here, I'm going to be using the ZenMap GUI version of Mmap. So it does use the Mmap engine, but it just makes it a little bit easier to see while I'm doing this live as a demo. And let's suppose the attacker has established that you have a network range in the 10.10.66, and he's identified that one of the targets he wants to have a look at is this 90 address. So we'll just do a quick scan of that for now. What this will do is go out there and probe the IP address, and it's come back and given me a list of services that are available. And of course, all those services that I had enabled on this decoy are now responding. So the first one at the top here is the FTP service. So that indicates to me as an attacker that I might want to now go and look at that machine and see if I can find some more details about it. So one of the things I might do is just see whether that it is available, but we already know that because the scan reported back saying there are services available. So yes, it responds to a ping. I'm going to quickly just check the FTP service, and indeed it lets me connect over FTP. And if I just highlight here, you'll see that this is where we made the change to the configuration. So you can make the decoys look and feel like real assets on the network very, very quickly. And that's one of the nice features of this deception grid solution. It's very straightforward to do. So we know that I've now got an FTP service running as a machine on the network. I think it's a real machine. So what I'm going to do here is just use my FTP client as it's a little bit easier for you to see from a demo perspective. And I'm going to connect to this FTP site to the IP address and log in as anonymous. So let's do a quick connect here. And it's going straight through to my FTP service. And you'll notice on the right-hand side, I can now see some folders. Now, you as the operator of the deception grid have created these folders on this decoy asset on the appliance. So these folders do not really exist on your network. These are completely fake file structures. But me as an attacker, I'm coming in to look at these, and this one here is quite interesting because it might hold something that I might want to have a look at in more detail. So I like to look inside this folder, and indeed I see a passwords.txt file. So that to me might be quite valuable. I might want to remove that from your network, and I take that down to my local machine. But of course, while I'm here, it might be quite nice for me to leave you a little bit of ransomware behind and to wreak some havoc on your network. So I'm going to upload some ransomware to your file transfer server, and then once I'm done, I'm going to disconnect, and my attack or my data exfiltration has been completed. So let's now take a look at how we see that on the deception grid. So I'll go to my analysis screen here, and you'll see that I now have some activity. In fact, if I was logging in from the dashboard, you will see the dashboard has lit up now. I have some traffic events happening, and I've got 5 trap events from some low severity scans right through to high severity interactions. And of course, if I go into my analysis further, you will see that on here. So we have some scan events that are occurring on the network, and these really were, as you saw, the Mmap scans to determine what's going on, and also the ping I did, which was to see if the service was alive. So everything there is recorded, but this one here gives me me much more of a high risk severity event. So you see here the red dot indicates it's extremely severe. I need to go into this one and investigate this one further. So what do I see? First of all, I see that I have an attack coming in from an IP address 201. It's using a Windows device to connect to a FTP service on the network on IP address 66.90. And of course, we all know that that was my fake FTP service. And we responded as if we were the Windows 2012 server. And you have a complete transaction here of the activities. So if I scroll down, you'll see I connected, and then I went into the IT admin folder and I retrieved the passwords.txt file from that service, which you have placed there as a complete fake decoy piece of information just to entice me into your deception. Also what we've recorded as a high severity event here is an upload of a file. So a binary file has been uploaded into my trap, and we have recorded that as the last activity that that attacker did before he disconnected. Now, a couple of things happen here. We take that binary file and we identify the MD5 hash of the file as it's shown here. And we take that hash and we send that to VirusTotal. That's one of our configurations in the platform. You can actually insert your own API from VirusTotal, and it's very easy to get hold of one, into the Deception Grid TSOC dashboard. And what it will do is it will send it over to obtain the references from, I think it's about 70 different AV vendors that VirusTotal now supports. When the file has been sent, the hash has been sent, sorry, the results will appear here to give you a score against it of those vendors. The second thing we do is actually take the payload itself and send it to a sandbox. Now, the Deception Grid default settings over here has an option to use the McAfee ATD service. Now, we actually provide this as part of our subscription, so you do not require your own sandbox. If you tick this option here and leave the default settings, then any of those binaries that we capture in the traps will be sent up to the cloud service for the file to be exploded, and that's fully inclusive in your license. So, however, if you did have your own sandbox, you can actually use one of the ones that are pre-configured here in this list as well. So you have the option of using the TrapX default or using your own. What will happen is the file will be exploded in the sandbox, and if I go to my forensics tab, you'll see the activity and the status of the files. Now, you'll see the last file to be triggered here was the trap of the file transfer server, and I've got the MD5 hash that we were sending over to VirusTotal, and we've got the 7.6 meg file that is currently being analyzed by the by the sandbox, sorry, and we are waiting for a result. So we'll come back there at the end of the demo just to look at what happened to my ransomware that was uploaded. Now, what I want to show you is how quickly it's possible to deploy a new decoy to your network. Now, let's suppose you require to deploy a new trap. I will, in this example, go into my wizard and deploy a brand new device, and let's call this demo trap and give it demo trap 1. It's going to just choose the next available IP address, and here we have IP address 120 available. I'll just leave the host name as it is for now and domain name as it is. Next, we decide what type of trap we want to configure, and rather than doing a workstation or server, this time I'm going to choose a networking device, and here I quite fancy deploying a Cisco device, as our network is using Cisco devices. So that makes it quite easy for us to create something that's quite realistic for my network, I'm going to select here Cisco Catalyst switch. I'm going to leave SSH enabled, Telnet enabled, SNMP enabled, TFTP enabled, but I'm also going to enable the web management for this trap, just so you can see something graphical on my screen. I click on finish, and now I have completed a deployment of a brand new trap on my network, and it really is that simple. So you see here I have demo trap 1 and IP address 120. So first thing I want to do is connect to that trap, and as you remember, I did actually enable the web interface for this particular service, and the default login for Cisco GUI is Cisco, and once I log in, what we'll see is a web GUI interface of a Cisco switch. And as that's building, you'll see all the components of the Cisco solution are now appearing, and this is in fact not just a screenshot, actually it is something I can move around and make changes to. So you'll see it is quite convincing as a decoy, and I have options to select things as I would do in a real situation. But of course, you did notice that SSH was also configured, and if I move down here and want to go and connect into the SSH interface, then all I need to do is connect to the IP address of that device, and I get given back a login prompt. And I log in here as a default login again, and I'm now inside a Cisco GUI, a Cisco command line interface. And next I can start running some Cisco commands, such as show version, and indeed gives me back the answers to my query. So a very convincing configuration. And as you saw, that took me less than 5 minutes to actually create brand new on the deception grid. And you know, today this could be a Cisco switch, but tomorrow I might decide that's actually going to be an OT device out in the field, or it could be a Linux server. So very customizable, very easy to manage without any complexities of having to deploy machines or devices on the network. So very straightforward. I'll just go back to my analysis screen so you can see some of the activity I've been doing here with the new trap that we created. So demo trap 1. You can see there was a HTTP interaction going on and also SSH interaction. So I'll expand my SSH interaction, and you can see here that we've recorded all of the activity I performed on that SSH login, and here is me opening up the shell and running the command show version. So we do capture everything that that user does, or the attacker does. Now, before I move on to very quickly showing you the tokens, I just want to show you what was going on in the forensic screen here. This file is still being analyzed by the sandbox in the cloud, but you'll notice that this hash of the file has actually been uploaded before. So I will show you the report of that. We'll come back when that's finished actually running. So let's go to my Windows 10 desktop. This machine here is acting as a corporate machine on the network. So this would be an employee's machine as it would be in the field. Now, what you'll notice, should an attacker gain access to this machine, one of the immediate things I might notice here is actually it looks very much like an IT admin machine because I've got things like WinSCP and PuTTY running on this device. The clue there is it's being used to do some sort of admin on the network, and that's actually quite high value to me because I can then start trying to break into machines on your network because I've got access to the tools. So let's have a little look around. I have one thing I might do first here is actually look at the host file of this machine. Let's bring up the host file. And the host file here is showing me some entries in the host file itself. You'll see here there's an entry for FTP server on IP address 90. Now, note that this has actually been added by me remotely. The TSOC has a feature to create the deception tokens that we can roll out to your network. And one token is editing the host file of the local machine. And therefore, should that machine be compromised, I might be lured into then connecting to this IP address, thinking it's a real machine. Likewise, I've also got entries here for a web server, for a printer, and also that Mac OS device. So host file is one of the first tokens that we can edit and push it out to the machine. Something else I might do if I was an attacker is run something like netuse and just have a look at some of the drives that have been mapped to this machine. And I can see here that I've got a share for a data folder, again on IP address 66.90. And as you remember, I configured SMB on that trap, which means if I were to open up a window explorer and go to that location, that I will actually see hopefully the data folder. And here we go. So I've now got access to the data folder. That actually is sitting on that trap on the deception grid, and I can explore that. And at the moment that one's empty, but if there were files in there, then I would see those files. Those files will be what you would deploy as decoy assets to lure me to go and remove those and think I've received something of high value. Interesting that this is shown up here in netuse. It does not show up in the normal My Computer folder. So your actual real users won't be accidentally tripping your traps. They won't see that that reference to that share. So some other things we do on this token rollout is, I mentioned PuTTY and WinSCP. One of the things we can do is send some fake data to PuTTY and send it down here in your saved sessions. So if I was an attacker and I wanted to just have a look at what sessions are in here, notice that I'm now connecting to an SSH interface, and I am logging in. First 3 times failed, 4th time I'm in. That's one of the settings that's available in our product. We can actually create the illusion that the attacker's logging in incorrectly, but on his 4th attempt, he gets access to this device. This actually is the Mac OS device. Again, completely false decoy machine that's built on our appliance. I can expand, I can peruse the file structure and see what's on here, just like I would do if it was a real machine. And of course, everything I'm doing here is being tracked by the Deception Grid platform. And just very quickly, some other things that we can do. If I open up my browser, we have the option of sending out things like bookmarks to the browser. And you'll see here, I've got some bookmarks on this particular browser, this Chrome browser. We support all the major browser platforms. We send out bookmarks. If I click on this one in the middle called reports, actually what it takes me to is an interface of a Lexmark printer. Again, this printer is running on the Deception Grid appliance. It doesn't exist in real life, but it looks and feels like a real machine. And one of the reasons we do emulate things like printers is more often than not, network printers will be shipped from the manufacturer with huge amounts of disk space and FTP enabled, and therefore they make great targets for an attacker to use to pivot to other systems and to store malware, etc., on your network. So very easy again to deploy, but here you'll see that I've now identified that you are running printers, and therefore I might want to do some more deeper dives into your architecture. And just to finish off here, I can also insert some history into the browsing, and therefore I can recall that browsing history. I'm using a tool here to scan my folders to retrieve actually the browsing history, but you'll notice that we've inserted some entries into the browser's history, and this would be something that, from an attacker's perspective, would be quite interesting data that I might want to retrieve, and therefore try to connect to these devices. All these devices are all running on my appliance in my deception grid. They don't exist in real life. So tokens are a very powerful feature of the solution. There's about 25 different types of tokens that we can roll out. We also are able to insert fake credentials into the credentials vault of the machines, so that if an attacker was doing things like a Mimikat style extraction of credentials, we can also place some fake ones in there, which means that you can then track usage of fake credentials. And if they are appearing elsewhere on your network, you can see that they have actually therefore been extracted from a decoy asset. So you know that you then have a problem with an attack that may be in progress on your network. So I'll finish here with a quick summary. We'll go back to my TSOC and just summarize what we've done here. So we logged in and looked at existing configurations of a trap, an FTP trap in this example, that was running on the machine. We then also attacked that from a perspective of an attacker coming in, doing a scan of the network, finding the machine available, connecting to it, pulling a file off, uploading a piece of ransomware to it, and therefore we captured, from a TSOC perspective, captured that whole journey from start to finish. We then looked at the forensics and analysis of that activity via the TSOC, capturing all of the high severity events and even the low severity events of the scans. We also sent files over to our pre-configured built-in sandbox, and here you can see that the sandbox has finished doing its job. I'll download that report while I'm talking. And also the interface into the VirusTotal to get the results of the hash of that file. Then we moved into the role of a user on your network whose machine had been compromised, and the attacker had found that he thought he was able to peruse your network and move laterally because we had left some deceptive lures to point him away from the real assets into fake assets. And all of that is done via a very simple configuration in the TSOC. So very, very straightforward to perform. Here is a report that comes from the sandbox. And what you'll notice quite quickly here is that I didn't actually upload any ransomware at all. The sandbox has correctly identified that what I did upload was the FileZilla client to the trap. So on that note, I'm going to finish our demonstration today. I thank you for your time. And just to remind you that if you do have any questions, then please do feel free to drop me an email to this address here at TrapX. Thank you very much.